The binary system. Now, the binary system isn't just a bunch of ones and zeros put together. What it is that these ones and zeros are a part of something known as the base 2 number system. So, a binary number is a number expressed in the true binary numeral system, or base 2 numeral system, which typically represents numeric values using two different symbols, typically 0 and 1. But nowadays, the binary system is used typically for coding and programming in laptops, phones, even in your credit card for banking. The binary system dates all the way back to ancient Egypt. The method used for ancient Egyptian multiplication is closely related to binary numbers. In this method, multiplying one number by a second is performed by a number of steps, which a value is either doubled or has the first number added back into it. The order in which these steps are to be performed is given by the binary representation of the second number. Now, this man, by the name of Gottfried Wilhelm Leibniz, was one of the most famous and avant-garde mathematicians of the 17th century. He invented a binary numeral system and showed that it could be used in a primitive calculating machine, which sparked the start of all binary achievements. Okay, before we start going on to examples, firstly, I'll show you the basic pattern for counting in binary. As you can see, 1 is 1, 2 is 1 0, 3 is 1 1, 4 is 1 0 0, and so on. You can obviously see the pattern. Okay, let's go into some examples. Okay, first of all, let's start off with an example of converting a base 10 or regular number to a base 2 or binary number. Then we will do it the other way around. Okay, let's start off with converting the number 22 into binary form. What we are going to do is to think about how many of each of these are in 22. Okay, let's start with the biggest one here. How many 16s are in 22? Well, there's 1 in 22. Okay, so if I use up 1 16, where there is still 6 left to make 22, so that means 8 is too much. So there's no 8s, but I do need a 4. There is a 2 there as well, so we can include that. So now we have a positive or 1 symbol on 16, 4 and 2. To make sure we are correct, we add 16, 4 and 2, and that gives us 22. So that means we don't need any 1s. So you've done it, you were able to convert 22 into binary form. Now, to change the binary number back, you just follow the binary number pattern that I mentioned earlier, and then you just write it down as a regular number. Thanks for listening.
Created using Powtoon.